Okay, we're going to take a close look at number 42 first. This is Fela's little sister, Cootie. Usually we get Fela up here. We don't usually get Cootie. How you doing there, Cootie Bug? Look at it. Look at that face. You did a pudgy face. Yes. All right. Okay, so this looks pretty straight like the other ones. We want to find the total area of the region between the curve and the x-axis. But look at some of the wording. They didn't say the region under the curve. They said the region between the curve and the x-axis, and they said the total area. So let's think about what this graph looks like. So, you know, one hand is on number 41 and 43. You're going to need to look at the graph. And I don't know which one of these. You can graph number 41 by hand. Number 43, you could graph number 43 by hand, but you don't have to. You can look at your graphing calculator if you want, but you could do it by hand. All right, let's look at the graph of 3x squared minus 3, right? So that is y equals 3x squared minus 3. I could write that as 3 times x squared minus 1. So I can look for the x-intercepts of this graph by setting this equal to 0. So I get x equals plus or minus 1. So this graph has x-intercepts plus or minus 1 and a y-intercept of negative 3, and it's a parabola facing up. I can get all that from the graph. So here's 3, here's negative 1, and here's 1. And I have my graph is a parabola going like this. I'm going to make it nice and wide. Because my interval goes from negative 2 to 2, right? From negative 2 to 2. So negative 2 is over here. Positive 2 is over here. So what's tricky about this graph is it has some parts that are above the curve and some parts that are below the curve. So I can't just, if I want the total area, so I want the area to be positive, I can't just do the integral because the integral is going to count the negative part as negative. But the total area between the curve and the x-axis means I want to count all these areas as positive. So I want to count this area as positive. I want to count this area as positive. And I also want to count this area as positive, but the integral is going to be negative. All right, so what do I do about that? I break up the interval. The interval is between negative 2 and 2. So I'm going to break it up like this. I'm going to say that the total area is the integral from negative 2 to negative 1 of 3x squared minus 3 dx plus, and I should have said minus, because I now have to put a negative, plus negative, we'll put it that way, the integral from negative 1 to 1, right, from negative 1 to 1 of 3x squared minus 3 dx, and then plus this part from 1 to 2, plus integral from 1 to 2 of 3x squared minus 3 dx. All right, that's how you have to split up the interval. You could do the rest of it from here. I invite you to do so, but I'm going to go ahead and do it, even though it's going to be a big pain and take up all my time. All right, so the antiderivative of 3x squared is going to be x cubed. Antiderivative of 3 is just 3x. And we're going negative 2 to negative 1. You got to watch all the negatives. This plus negative, I'm just going to make it negative. Right, why is this negative? Because this part was below the x-axis, so the integral is going to be negative, but I want it to be positive, so I put a negative sign in front of it. All right, so I'm going to go minus. So it's going to be the same antiderivative every time, so at least I don't have to worry about that. And then plus x cubed minus 3x, right? Same antiderivative every time. And this is 1 to 2. All right, so I break that up into 3 parts. I count a positive part, a negative part, a positive part. And I work it out from there. Okay, so to do this one, I have to plug in the negative 1 first. So I'm going to have negative 1 plus 3. And then minus for the fundamental theorem of calculus. Now I plug in the negative 2, and I get negative 8 plus 6. All right, isn't that awful? It's just going to be a bunch of signs. I'm going to keep this minus out here. I have to plug in the 1 first, so I'm going to have 1 minus 3, and then I'll plug in the negative 1, so minus. Now I'm going to have negative 1 plus 3, negative 1 plus 3. Okay, and then for this part here, I'm going to have plus, and now I've got to plug in the top, so I'm going to have 8 minus 6, 8 minus 6, and then minus for the fundamental theorem of calculus, and then put in the 1 minus 3, 1 minus 3. Right, so every one of them has f of b minus f of a for this one. F of b minus f of a, f of b minus f of a, f of b minus f of a. That's what's going on there. All right, now I just got to work out all the numbers. It's going to be a big pain to do. Let's see. So let's see how much of this I can do. This is going to be -2, right? So I basically have 2 plus 2, which is 4 right there. Here I have -2 minus 2. So that's going to be -4, but then I put a negative in front, this is plus 4. That, by the way, is a check on my work. This has to be negative because it's the part below the x-axis. So to put the negative, it makes it positive. All right, so curiously, this and this are the same. So now, by the way, I can conclude from the symmetry of the graph that this one's also the same. It's also 4. And it is. 8 minus 6 is 2, minus -2 is 4. It's 12. That total area is 12. That's crazy. This is 3, this is 3, and this is 3. Come on. I mean, they're 4, actually. This is 4, this is 4, and this is 4. How unlikely is that that whole area is 12? Well, it is. All right. I think I really only want to do, well, I want to do 2 more, so yeah, I guess I'll bust it out into another video.